This unit is on sound. Sound is a mechanical and a longitudinal wave. The larger category is mechanical wave. You already should know what it means to be a mechanical wave. It means the wave needs a medium. You also should already know what it means to be a longitudinal wave. It means that the particles of the wave travel parallel to the direction of energy, or the direction that the energy travels through the wave. A new term would be the term pitch. Pitch means frequency. Pitch is the tone. You have a high pitch or a low pitch, a high C or a low C. I can also use the word note. All three terms are synonyms of each other. Most of the time we'll use the frequency of the tone or the frequency of the pitch, especially when we're dealing with our lab. Another term that you need to be familiar with, and hopefully you already are, is the amplitude. Amplitude has to do with the loudness or the sound level. Turning up a volume turns up the amplitude. Amplitude is measured in decibels. You should be aware that decibels are not measured on a linear scale. They are measured on a log scale, so that if you double the decibels, you've more than doubled the sound level. We'll talk more about this in class. There are two equations that we're going to, well actually there are three. The two on this page are, one you're already familiar with, velocity equals frequency times wavelength. The other you're not familiar with is the speed of sound in air. The speed of sound in air depends upon the temperature of the air, and as you can see from the equation, as the temperature increases, the speed of sound increases. The last thing we're going to talk about, in this section, the 0.6 times the temperature is like a correction factor. If it's 0 degrees Celsius, the speed of sound is 331.5 meters per second. If the temperature increases, then the speed of sound increases. If the temperature decreases, the speed of sound decreases. The last thing we're going to talk about on this page is the relative speed of sound in a solid, liquid, or a gas. The speed of sound is fastest in a solid, then a liquid, then a gas. So one of the things that's going to be a little difficult for you, at least initially, to think about is that if the medium in this case is more dense, the speed of sound is faster. This is true because sound is a longitudinal wave, and with longitudinal waves, the molecules vibrate and pass the energy along by vibrating against each other. The more closely compacted those molecules are, the easier it is for the energy to be passed from one group of molecules to the next, which is why the speed of sound in a solid is greater than the speed of sound in a liquid, which is greater than the speed of sound in a gas. It has to do with the relationship of the molecules with one another. The last equation you're going to deal with is the perceived frequency, and the perceived frequency that is heard deals with the Doppler effect. We've already talked a little bit about it. You guys know that if the object is moving towards you, the perceived frequency is higher than the actual frequency. If the object is moving away from you, the perceived frequency is lower than the actual frequency.